Hi everyone. I hope you have liked my previous videos of microservices deployment series. This is final part of same series. In this part 4, I'm going to cover stateful set, service mesh using Istio, Kubernetes package manager using Helm chart, and EKS log management using Container Insight. So let's get this started. Okay, so let's first understand what is a stateful set. Stateful sets are intended to be used with stateful application and distributed systems. If you try to understand, what was the reason behind microservices deployment or going through microservices architecture, the primary reason was to build a stateless application or stateless services. A stateless application is one that does not care which network it is using, and it does not need permanent storage. Example of a stateless app may be a kind of web server, right? Or maybe different microservices which are not dependent on any network path. So for example, say if your call is getting served, one part of call is getting served through one pod or one VM, and the next part of the call is getting served from different pod altogether, it is not going to impact your application functionality at all. Whatever deployment we have done so far using deployment object of Kubernetes, they all were stateless in nature. Now, what are the scenario when you need to build the stateful application? Ideally, this is not a recommended approach for the microservices architecture, but there may be a scenario where you need to build it. So let's take an example of any database, right? If we talk about a database like MySQL, there may be a multiple deployment in the database itself, like the primary, which is the write nodes, or it can also be used for read and write both, and other nodes like read-only replicas. So if you need to write something, insert anything in the database, or maybe edit anything in the database, you need to connect to always a write node, wherein read can be done from any other node, right, including the first one and the read replicas as well. So if you build this architecture, your write will be deployed on one pod, and your read replicas will be deployed on different pods. And if you expose them via normal service, so it is going to be load balanced, right? We have seen that. So if we are going to use the same level across all of them, they are going to be load balanced. And the most important challenge you are going to face is if pod is died out, and once it is coming back, it is going to take a different DNS name altogether. So how stateful set is going to help us out here? So let's understand how stateful set works and why it is required. So we have deployed multiple pods and applications in our earlier sessions. So how does deployment works, right? If I need to deploy anything through deployment object, for example, say I'm deploying one service and there are multiple pods. Pods are getting deployed. Say I'm giving the replica set 3, so basically 3 pods will be deployed of same service. And if you are going to call a service, going to execute the service, call will be served either by any one of the pod, whichever is available, and your service will act as a load balancer. In stateful applications, our requirement is a bit different. We need more control on a particular pod. So if I need a connectivity from this particular pod only, I need to ensure that every time I'm going and making a call either directly or through service, I'm getting this pod or serve my request. Okay, let's understand this. So in stateful set, for example, say you need to deploy 3 pods of the same service. So pod will be deployed like this one, P1, P2 and P3. So from deployment point of view, it is going to be same. There are 3 deployment based on the replica set. There are a couple of differences. The first thing, it will always deployed in a proper order. So first pod will come into existence first, then this one, and then this one. So there's a command of rollout which you can fire and then understand how pods are getting created one by one. So this is the first difference between deployment and stateful set. And even if you kill this this service, they are going to delete it in the exactly reverse order. P3 will go first, P2 will go next, and then P1 will go. The first difference. Second, if you have seen, whenever the pod is getting created, you must have seen a random name, to the pod, right? And whenever pod is getting killed, a new pod comes into existence, it will take a new name altogether. But in case of a stateful set, the DNS for this P1, this pod P1, P2, and P3 are going to be maintained. So whatever the name of a stateful set you are going to give. So for example, say I'm going to give a name of my stateful set as a MySQL. So the first pod will be created with the name MySQL-0, second MySQL-1, and third MySQL-2. And they are always going to take the same name. For example, say a pod 2 is getting deleted, due to some reason, and it's get created because of, auto scalability feature, it will always going to take the same name MySQL 2. So you can call a pod with its name all the time. So it is going to maintain the DNS name. The third important feature is headless service. It's not related to a stateful set, but we have seen a service, we have created a service and that acts as a load balancer, right? And we can get this, created using the cluster IP, node port, or load balancer. But in case of stateful set, there's a requirement that, okay, always the first pod should be getting returned, right? For example, say if you are going to create a database, your first node is going to be master, nodes are going to be read-only replicas. And if you want your service to return always the first node, you need a different service altogether. Headless service does exactly the same job for you. So to create a headless service, everything, whatever you have done to create the service, you're going to follow the same thing. The only difference is that you need to add one more parameter there, which is known as cluster IP is equal to none. So we'll see that in example. So let's execute the command and then try to understand how this works. I'm inside my MySQL folder. I'll give you the link of the GitHub, and you will find all code there. If you see, I have created 3 files there. That is MySQL config, MySQL service, and MySQL stateful set. I'm not going to explain you the feature of MySQL here. I'll just explain you the stateful set and how this works, right? You can just go through the details of this YAML file, which is available in GitHub, and try to understand if you are interested in MySQL part. So this is the config file. If you have gone through my last video, I have explained the storage part for the stateful set. Just go through that. Config map is also a kind of a storage which can be used to inject a config information to the your stateful set. So I'm just using some MySQL related config here. This is pretty straight. You can Google and try to understand how this works. So if you see, I'm creating 2 services here. The first service is my headless service, where I'm saying that cluster IP is equal to none. There's no difference in other parts. The name of this service is MySQL, right? And this is also using the app is equal to MySQL, which I'm using in the deployment part of a stateful set. And the second service is a normal service where I'm not saying anything. So by default, it is going to be created as a cluster IP. All right. This is your stateful set. It is more or less similar to the deployment. The only difference is that you need to mention the kind as a stateful set here, right? So I'm deploying, if you see, more or less it is going to be look like, deployment part. Just go through that in detail if you want to understand that, but this is more or less going to be same. The only difference is that when the deployment is done, it behaves differently, right? So I'm installing, the image of MySQL here, and there are, couple of MySQL related configuration here, right? So just go through that if you want to understand this. I'm not going to explain, as I mentioned. Let's go and deploy it. So first, if you see, let me go back to the code. So all the deployment of this I'm doing in the namespace MySQL. So I need to create this namespace first. is created. Now let's deploy one by one. Same command. Now let's see what all components has been deployed. But before that, let me execute a command. So when stateful set are deployed, you can check using rollout command how deployment is done. It will always maintain an order. Let me just show you first and then I explain. So it has deployed one pod and waiting for two pod to be ready. So one most important feature of stateful set is that whatever the pods are going to be deployed, the order will always be maintained. So the first pod will come into existence, then the second pod, then third pod, and even if you delete the stateful set, it will also always get deleted in the reverse order. So this order is also always maintained, and that is important feature of any stateful set and any stateful application as well. Let's see. Get all. Now see. So this is the stateful set deployed 3 by 3. These are the two services. This is the headless service where cluster IP is equal to none, and this is my normal service where cluster IP is given as an IP. Okay. Now Replicaset I have given 3, and that's why 3 instances are created. The interesting part here is that if you have noted earlier, the random name has been taken for the pod, which could be used as a DNS. But if pods get killed and new pods come into existence, the name gets changed, wherein in the stateful set it will always going to be in a proper order. So the first pod is always going to get a name of whatever the name you have given, -0, then -1 and -2. So even if you kill this pod, the new pod which will come and get created in place of it is always going to get the same name. And this is an important feature for this. Okay. So let's execute a couple of commands. Let's see, the volume which we have attached here is created or not, to ensure that MySQL is up and running. If you see the code, I have already used the PVC there, so I'm just verifying the yeah, it's up and running. 3 volume for 3 instance of MySQL. That is, first is the primary is the right one, and that is a read replica. If you need to write something, I'm going to execute a command. This is specific to MySQL, wherein I shall be using the MySQL client. I shall be running temporarily, and then create a database in the my right instance, which is the MySQL -0. Just have a look. So here I'm running MySQL client. Runtime I'm giving the image name, right? And I'm just connecting to my first node, which is my write replica, MySQL -0 dot MySQL, which is a namespace, and then I'm creating a database and inserting a message here. The important thing to note here is that I'm using the name of pod, which is a DNS name, to connect it. So even if this is getting killed, as I mentioned, the name is not going to change. The DNS is going to be same. So this command is going to work all the time. Let me execute it. It's done. Now let's read it. I'm again using the client for reading the information from once from my read service. So what read service is going to do, it is a normal service and it is going to read from any pod which is available. Yeah, let's loop in it. So this is going to loop the command and reading the information from here, and then printing the server name so that you can understand that how normal service load balance the call. So every time the response will be coming from different server altogether. So server ID is 0, 1, 1. All right. So let's understand the headless service with another example. I have created one stateful deployment. This is not new to you. So basically what I'm doing here is I'm creating one service here of inventory SVC, that is the name, and I'm giving the cluster IP is equal to none. So this is a headless service, right? And using the app level inventory, and I have created another service with the name inventory SVC normal, right, for the same app level. So basically they are going to serve the same set of pods, and this is the stateful set. So I'm going to deploy two stateful set because I want to give a different outcome from both, so that you can understand the output is coming from different pod altogether. So this is the stateful set. I'm using the same app level here, and here if you see inventory services deployed, we have seen this earlier as well. And the second stateful set I have created with the same label here, so that the service can call both one by one depending on which service we are using. And here I'm using the new service. So basically the message is going to be different. Let's deploy it. Okay, so I've done the deployment earlier, that's why it is giving unchanged, but in your case it will be giving a deployed message. Let's see what has been deployed. Yeah, so basically two pods are running, inventory 0 and inventory 1-0. Technically both are different stateful set altogether, but since we wanted to see the different messages coming, so that we can understand how pods are getting served, I've used two different stateful set, but since I'm using the same level, so service is going to call them one by one depending on which service I'm going to use. In case of inventory SVC normal, it is going to load balance because this is a normal service. But in case of inventory SVC, since this is a headless service, cluster IP is given as a none, it is going to always return the first one, right? To call this, since these are exposed via cluster IP, I'm going to log into one of the pod. So remember the command kubectl exec -it. So I'm inside it. So now let's first execute inventory SVC, right? Curl command, curl, and the port which we have given is 8081. So message is coming from inventory update started, because if it is coming from new inventory, it will be giving a message new inventory update is started. Let's repeat it a couple of times. See, it's always returning from the first pod. Now let's try the second one. Inventory SVC normal. First pod, then second pod, first pod. So it is load balancing. So this is the basic difference between headless service and normal service. Normal service will load balance based on the label of the pod, but in case of headless service, even single stateful service and you have deployed multiple replica set, it will always return the first pod. All right. Okay, next we are going to cover Istio, which is a service mesh. So let's first understand what is a service mesh. A service mesh is a network of microservices that make up applications and the interaction between them. So why a service mesh is required? There are a couple of things which service mesh does for you, like discovery, even the load balancing, failure recovery, that is a retry logic, observability, that is a metrics and monitoring of your services, A/B testing, which is a blue-green kind of testing, canary release, where you want to release some a new code to some set of people. Even you want, if you want to control the rate of your services execution, that can also be done using the service mesh. And the important feature is that it can let you implement authentication and authorization on across all services. The most important feature which I'm going to cover in today's session is the network monitoring part and network flow part. So basically, when you deploy any application, the call is going from one service to another service, depending on how exactly you have written your flow as per your business requirement. But if you want any control between those flow, execution of those network flow, how would you do that? Service mesh let you intercept the those calls and write your policy, and based on the policy, this execution can be diverted. So let's first understand this. So to explain service mesh, I have opened a Nginx page where they have beautifully explained what service mesh is all about. So if you see, there are two different parts of a service mesh. One is a control plane and second is a data plane. So whenever you deployed a service mesh, or service mesh is enabled, like in our case, the example we are taking Istio, in the data plane, whenever an instance is deployed, the pod is deployed, so your service mesh inject a sidecar proxy which let you intercept the call, right? And this is managed through a control plane. So control plane let you manage the policy, how your traffic should flow, and the interception is done at the data plane level using the sidecar proxy. Okay, and through this architecture, you can get the observability and traceability of your complete service mesh through control plane. So we'll see that in the our demo of Istio. Let's understand the application structure. So to understand the Istio and service mesh, I'm going to deploy one application which is known as MyWeb, and this MyWeb is going to call a service MyData. And in MyData, I'm going to deploy two different pods. When I'm saying two different pods, it means it's not a going to use the same code. This is pod 1 and this is pod 2. So I'm going to deploy a different deployment unit with the pod 1 and pod 2, but through labeling, I'm going to use the same label. That's why the MyData is going to call the pod 1 and pod 2, and it is going to load balance. So every time call is going to be distributed across these two pods. And through Istio, we will intercept it here through virtual service. I'll explain you in some time what are the components of Istio. And in virtual service, we'll write some logic, that is a policy that okay, maybe 20% call should go here and 80% call should go here, right? So we'll understand in detail. So as we saw, the important component of any service mesh is a virtual service, which let you intercept your service calls. Another optional component is a destination rule, which let you write further logic on your network flow policy, and the gateway, which controls the flow of traffic into and out of the service mesh. Behind the scene, a gateway is an envoy proxy instance deployed in a standalone configuration, not attached to any application container at the notional boundary of the data plane, right? So let's try to understand this through our code. So first we need to understand the deployment part, right? I'm not going to deploy it because I have already deployed a service mesh, that is Istio. Let me show you the deployment part. So this is the namespace created for your Istio system, if that is deployed properly. Let's try to see what exactly, what all components are deployed inside this. So as you see, there are multiple components, but a couple of things, I would like to explain here. So basically the Grafana we have already seen. So Grafana is also a part of Istio, which let you manage the metrics of your service mesh. This important service which is deployed here is Kiali. I'll explain you what exactly this is. This is a dashboard which let you manage your mesh. So let me try to find ingress command, that is ingress object. Yeah. So this is your Istio ingress, right? So whenever you're going to deploy any application, the first call which is coming to service is getting intercepted by this gateway, and a load balancer is already exposed via this IP. This is the load balancer IP, and whatever the port of application you are going to assign, you can access your application via this URL only. You need not to expose any different load balancer for your application. So all the application which are going to deploy inside that Istio will be accessed using this URL only, which is a part of your Istio deployment itself. You just need to mention a different port here altogether and you can access it. Okay, so once our deployment is done, we are going to use this URL with port number which we are going to provide in our application, and we are going to use the Kiali, access Kiali for dashboard. I'll explain you what exactly we can do using this one. Okay, a part of the other things, they are part of your Istio deployment only. If you want to learn more, you can go through their site and try to understand through documentation. If you need to deploy Istio, you just need to follow a couple of steps here. You just access the Istio URL, and there's a deployment steps given there. Just follow one by one and you will be able to deploy it very simply. It's not that complicated. You just need to ensure that you are following all the steps, and once the deployment is done, you will be able to see that namespace, and then inside that namespace all the components should be up and running. All right, so let's deploy one application. Okay, so I'm going to use this namespace to deploy my application. Whenever you're going to deploy any application and you want service mesh to be integrated there, you need to ensure that whatever the namespace you are going to use for deployment, either default or any other namespace, you need to enable Istio integration there, and there is a mechanism for that. I'll walk you through. So let's see the application structure. This is the application which we are going to deploy. But before this, let's enable the Istio on our namespace. The command for same is, you need to enable a label. kubectl label namespace. This is the name of namespace where we are going to deploy our application, and the label should be always Istio-injection enabled. Right? I believe I have already done, but let me just execute the command. And to verify this, if this is done, you just need to execute a command to verify the label for your namespace. kubectl get ns, test ns, and show label. So it says that label is already enabled there. That's all you need to enable Istio. Once deployment is done, create a namespace for your application and go and enable a label there with this name. And that's all. Just go and deploy your application. Istio will by default inject the Envoy proxy on all ports, and through Kiali dashboard you will be able to see that. So we'll see in some time. So let's see first the code part. So as I mentioned, first you need to create a gateway, right? So gateway is an object which let you come inside the mesh, and using URL you can call your application, right? So what I'm saying here is that, what is the namespace? This is the name of Istio Ingress, which port I'm going to expose for my application. And here you can define from the security point of view host name. The host name is going to be a URL, that is a load balancer URL of Istio, which I have mentioned there. For simplicity, I'm keeping it star, but you can mention the URL here. And if you see that I have created a virtual service, this virtual service is for the injecting first call to your application, that is the web application. So if you see there's a web application, I've already explained you, and there are data service, internally data service is calling these two data pods. I'll explain you in some time through code. So this is my virtual service, and this is a mechanism of writing the virtual service, right? And this is the calling a host myweb. So myweb is a DNS name for my application, which is a service name. If you see myweb, so basically gateway and virtual service I'm creating only for myweb. So I'm intercepting my web call, but I'm not distributing any load as such, right? It's coming as in a flow. I'll be creating a separate virtual service for this data service, where I'll explain how this can be intercepted and policy can be written to distribute the load, right? So it's all about managing the network traffic. This is a myweb. This is a simple application exposed via port 80, and internally it is just using the label. If you see the service, yeah, so it is expecting a label myweb, right? And this is a normal deployment part of application. I'm using Nginx. It's a standard Nginx for deployment, and I'm injecting some piece of HTML code here. All right, now this is my data service. So in the first data service, that is basically first pod I'm printing a different color yellow, and the second pod I'm printing a different color gray with different messages altogether, and I'm just creating a one service for my first pod. So it's all about using the two different application with the same label. So the call will come to the my data and getting distributed across both pods, because the label is going to be same. So if you see the service is here, and deployment, the pod is actually I'm using the same service, that is the my data, right? So this service, when call is coming from my web to my data, this service is getting executed, and this is expecting a app, that is a label of app my data. And this is my first pod, and this is a version 1, but I'm v1, I'm not using it, I'm just using this label. If you see here, right, app part only. And if you see the second part, there is no service created. I'm just directly deploying the pod here, and now using the same label, but it is printing a different message altogether, right? So what is going to happen, if you remember in the second video, part 2, I've explained you can deploy different application and expose via the same service. The only thing you need to ensure that the service which you're going to use, whatever the label it is expecting, you need to ensure that the same label is used across multiple applications. That's what I'm doing here. So call will be distributed across both pod, which is a standard practice for the same label if you are using, but you're going to get a different message altogether because both are different application altogether. So let's go and deploy it. So I'm going to apply, okay, this is application. I'm going one level up, and I'm going to apply -f on the folder number so that all components of folder can be deployed here. Done. Now see what has been deployed. Test NS is the name of namespace. Get all. Yep, it's initiating. So basically 2 pod for my data, v1 and v2, and this is my web, and 2 service. So my data is going to call load balance between these two, and my web is going to call this one, right? The virtual service and gateway which you have deployed will not be listed with get all. You need to fire a different command altogether. Let me execute it. kubectl -s -n test ns get gateway. Either you type GW or write a complete name gateway, it will list. This is my web gateway. Okay, same for virtual service. Either you type VS or complete virtual service name. This is virtual service. Right, now let's open the Kiali. kubectl. Let me find the IP of Kiali. So this is deployment. This is Kiali. Kiali is deployed as a node port. You have an option. You can go and open this, just change, edit it, and deploy it as a load balancer and use the load balancer to access it. I'm going to use the node port to access it. The port which it is using is 30522. Okay. Now I need an IP of public IP of my node. We have seen this command kubectl get nodes -o white and pick any IP. Let me pick one public IP. This is 30522. Yeah, it's working. The default login for Kiali is admin and admin, ADMIN, and the same is the password. You can change the password later on if you want to. Okay, so this is the application which we have deployed, and if you can see, two applications are running here. Let's go inside this. So it is listing down the same services which we have deployed, my web and my data. So Kiali is a use for observability of your service mesh, that is Istio service mesh. If you want to understand the complete traffic through graph, the best way is to click on graph. So let's first execute the command to see if application is working. To do this, as I mentioned earlier, you need a URL of Istio Ingress, and since we are using port 80, we can take it from there. So where is that? This one. Okay, let's go back. Since port 80 is there, so I'm just directly now see this is calling v2, and if I keep refreshing, since my data service is load balance across two pod where different applications are configured, you will be seeing a different message here. See, okay, let's put some load on this call, and then we'll be able to visualize this in a better way in Kiali. New tab, and I'm just going to use the curl command again and again through watch. So watch is the command which is going to execute this rest of the code every 2 seconds, right? Now let's go back on Kiali and see if it is getting visualized. Yes, it is there. Let's wait for some more time. And so here, if you see, there are multiple options available, right? You just need to select the version graphed, because we are using two different versions of the my data service, so it will visualize you correctly. Now see the complete flow. You can see call is coming to Istio Ingress. From there it is redirecting to the my web. It's v1 is being used, that is a pod. It is going to my data, and since my data we are using two different pod with two different application of v1 and v2, the call is going here. If you want to see the complete flow, you can select here from display, just enable traffic animation. Now this animation is there, and if you want to see the percent of distribution, how call is getting distributed here, from this here you can enable request percentage. Now see, it's not exactly 50% you are seeing here, because this is just a calculation. At a one point of time, there's a possibility that one or two calls are more on on one side, but yeah, it is a 50% distribution, right? Now the most interesting thing is that if I want to control the traffic of my data for these two pods, how would I do that? There are multiple mechanisms of controlling the traffic. The one is a weighted call, where you can say that 70% calls should be going to V1 and 30% calls should be going to V2. Or maybe just take a scenario that you have deployed one application which is a different single time of application, that is V1, and now you are changing the code and you're going to deploy a new version V2 of the code, and you want to ensure that not 100% people are going to use this V2. You want to just ensure that okay, only 10% people should be using. You can apply a weighted network logic here. To do this, you need to build a virtual service over here, and in the virtual service you can go and say that okay, 80% or 90% calls should be going to V1 and 10% calls should be going to V2. Apart from virtual service, you can also optionally use destination rule as well, where you can give some additional logic there. So the one way is that from CI/CD point of view, you should be having understanding how virtual service is created. You will be creating a YAML file of kind virtual service, and putting your commands there, and then deploying using the same kubectl apply logic, right? But Kiali gives you mechanism using graphical interface. You can do this, and it will by default go and deploy the virtual service as per your rule which you are going to apply. Let me explain you how to do that, and then we'll see if virtual service is created there or not. So I want to create a virtual service here. To do this, just right click on the service, that is a my data. There are multiple options available here. You can see the traces, inbound map, metrics, and even traffic details. We need to click on the show details. So click on action and create a matching routing pattern, or maybe weighted routing. So we are going to use the weighted routing. There are multiple mechanisms here. Just go and read it in the documentation. I want to keep it simple so that as a beginner you can understand the logic, how to put it. So you can put different logic once you are able to understand the basics, right? So I'm clicking on the create weighted routing. Now see, this is the default setting here. It's not coming from virtual service. Kiali understand that you have not put any virtual service and you have just using the label to distribute the load between two pods for a particular service. It will give you 50% weighted logic here. But the moment I'll change here, for example, say I'm saying that 80% call should be going to V1 and 20% call is going to V2, and the moment I'll click create here, it will create the virtual service for me and deploy it. Okay, let's click on the create. Done. Before seeing the result, let's see if virtual service is deployed here. -n test ns get vs. See, this was the default one which was deployed by us. This is the new one. If you want to see configuration details, you can go and open through the describe command, the way we were doing for pods earlier, or through Kiali also you can go and come below. Here you can see the virtual service is created for this service. This is the virtual service, and there's a destination rule also created. There's nothing much here. You can also look into the destination service. This is an optional to give you some more logic, but the logic for redirection is going to be part of the virtual service only. Just click here, click on YAML, and it will give you all details. The exception which you are getting here, this is there's some issue with the Kiali version itself. That's why you are getting that, but it is not going to affect our application. Let me see if I can change the font. Yeah, see, kind is virtual service. There are a couple of more information, weighted logic, but the important part here is, see, the destination, which says that 80% on the V1 and 20% on the V2, right? Now see if this is happening. You will not see exact distribution, but yeah, close to that, we will see that. Let's go on the graphic part of graph and see 86-13. This is because of the mathematical calculation, but it is very close to 80 and 20 actually. All right. So this is what a service mesh is all about. Either you are using Istio, you are using app mesh, or any other service mesh. They are going to do the two basic thing for you. One thing is intercepting the call through virtual service, wherein you can write your policy, how distribution should take place using different mechanism. We have seen the weighted one here in the Istio, and there are other mechanisms. Just go and read the details of Istio in the documentation, and you'll be able to understand. All right, that's all guys from the Istio point of view. Let's jump to the next topic. So we'll understand what is a Helm, right? Helm is, in a simple term, a package manager for Kubernetes. So you must have seen different package manager in Linux world. Helm does exactly the same job for Kubernetes. So for example, say if you need to deploy an application, there are 100 of YAML file, and if you go and deploy them separately, that doesn't make sense. You will not be able to manage the versioning and other parts. So Helm let you create a structure for those all the YAML files, and you can go and deploy them in one go, and you can also maintain the version for that particular deployment, and you can also roll back as and when required. Okay, so let's understand how this works. The deployment unit in Helm is known as Helm chart. So whatever we are going to deploy, we'll call it Helm chart. If you see this my API inside this folder, I have created a Helm chart with name my API. I'm going to deploy one or two application inside using Helm. I'll explain you in some time what those application looks like, but fundamentally they are simply services and deployment objects, and there are multiple services I'm going to deploy through Helm. Let's go inside this my API first. So the structure of Helm, right? We need to keep file in a particular structure. I'm not going to include all the structural details. I'm going to explain you. I'm going to talk about the basics so that you can understand as a beginner. Let me just use the tree command to give you the structure of this. This is the bare minimum requirement for creating any chart. So whatever the deployment package you are going to create, you need to create with a particular name. So in this case, I have given my API, and inside this folder, you need to first create a chart.yaml file. Then you need to create a folder template. Inside this template, you need to put all your YAML files. You can put in any order. You can create a single YAML file and put all the code inside that, or you can create 100 YAML file. That doesn't make any difference from the chart deployment point of view. And then on the root itself, along with the chart, you can create a values file. This is again optional, but this is important because it let you, change the configuration details of your code, right? So let's first understand, what exactly how chart looks like. The structure of chart is pretty simple. This is the name of my chart. This is a little bit description. You can put more details here, but important thing is that what is the type of application. This is for you. This is the version of chart. So whenever you are going to deploy a chart, the recommendation is to go and change the version of this one. So maybe you can start with 0.1.1, but after 1 hour, maybe after 1 day, if you are going to redeploy it, usually it is recommended to go and change the version here, maybe a minor or major version depending on how much changes you're going to deploy. And this is your API version. So this says that whatever the API you are going to deploy, that is a business call, right? You can change the version. So for example, say if my functionality is changing a lot, so this is from the technical point of view, that is a chart deployment, you're going to change the version every time. And this is from the API point of view. So there's a possibility that you're going to deploy your application again and again, and you want to keep the same API version. You don't change this, but this should be always changed. This is the recommendation. So this is the basic minimum thing in the chart itself. Now let's go inside the template. I'll walk you through the values part at end. CD template. So my application contains multiple YAML files. That's why I have given here. So I'm deploying, one application using first app YAML file and second with this one, and there's an ingress getting deployed. So let me open one. Let me open all. So these are the standard deployment. You have seen this. The only difference is that if you go and deploy, put that as is, and you are going to Helm deployment, it is going to, deploy that as is. But if you want to change some configuration at the runtime during the deployment itself, how would you do that? So for example, say there's a Replicaset, right? You can go and hard code that one or two, and whenever you go and deploy it, it is going to be deployed whatever you have hard coded in the YAML file. But if you want to, Helm let you change that at the time of deployment itself. How you will do that? That is the value file. So you can put those configuration details in the value itself, and even you can pass at the runtime itself, right? But how would you read the value from value file? That is the part of the Helm chart, and then replace in your YAML file. Let's see how that is done. So this is the mechanism. To Replicaset, that is you can give a hard coded value here, or you can give the value starting with two braces, then dot values, and this is the part of your configuration itself. You can choose any name. I'll show you structure why I'm using the replica count dot first service. But yeah, this is you can define in the values file itself. That is a part of your chart, and this is need to be done exactly the same way. So throughout the application, I am the replica set. Here in the first application, I'm using the replica count dot first service name, and in the second, I'm using the replica count dot second service. All right, let me show you the value for it. Go back, code values.yaml. This is part of your chart. So I have given the nested value. That's why I was mentioning you can give simply first service and the second service. Then you need to mention over there is dot values dot first service. Since I have given the nested value, I'm mentioning that dot values dot replica count dot first service. This is how this is given. So if you don't pass anything at the runtime, you just go and do the plain vanilla deployment. I'll show you how that is done. The value which I have given this in the this values.yaml file will be passed as a parameter. But if you want to change the value from 2 to 3, you need not to go and change it here. You can do it from the chart itself at the time of deployment. Okay, let's see how deployment is done. So to deploy it, you need to come back. Yeah, this is my API file. So I should be one level up of the main folder. So before deploying our chart, we need to deploy Helm. To install Helm, you need to go through their site and go through the details. There's a step-to-step process how Helm is deployed. So based on your operating system, you can choose one and deploy it. This is pretty straightforward. So I'm not going to walk you through all these steps. So you can deploy through a script, you can deploy through package manager, you can deploy on Windows system using Chocolatey. So there are multiple options. On Mac OS through brew command. Okay, now let's see how to deploy our chart. So once Helm is deployed, we have already created our chart. Let's deploy it. So what I'm doing here is Helm install. This is name of my Helm deployment, and this is name of my chart. I'm using the same name, but there is a caps here, right? And these are the optional part. So you have seen this in the values, right? Values.yaml. So if you will not pass these values, it will take from hard-coded value which you have given in the values. If you remember, I've given for the first service as a 1 and second service as a 2, which is used as a replica count, right? But I want to change it at the time of deployment. I'm giving it both values as a 1. Let's see if this works. Deployment is done. Get all. Now see, these are the normal service and these are the new inventory and new order. This is a service 2. The values are 1 1 because we have passed from the outside. Now if you want to control the complete deployment, right, you just need to see the Helm deployment. Helm list is giving you the name of deployment, my API, namespace default. We have not mentioned any namespace, and this is the app revision version. This is coming from here. It's coming in the second line because I have using the larger font. This is updated date, status, and this is your API version, and this is your API version, and this is your chart version. Okay. Now if you want to change the deployment part, again you need to deploy. For example, say if you want to change the second service Replicaset as in 2, right? So rather than using the install, you will be using the upgrade command. Same thing, Helm upgrade, my API, rest of the things are same. What I'm doing here is that the replica count for service 1 is equal to, I'm putting as in a 1, but this I'm changing as a 2. I have not done any changes in the values.yaml file. That is still the same. The recommendation is go and change the version of chart, but this is a demo, that's why I'm not changing it. Let's go and upgrade it. Done. Let's see the list. The revision is changed as a 2. So this is the version of your deployment, and these are the version which you have given in the chart file. kubectl get all. Now see, these are 2. Now if you want to roll back, how would you roll back? So there was a version 1, revision 1 and revision 2. Let's say you have done deployment of revision 2 and accidentally and you want to roll back to 1. How would you do that? Pretty simple. Helm rollback, name of your deployment, 2 1. Done. Let's see the Helm list. This is the version 3. It will not show you 1. It will always increment, right? But it is exactly the same of version 1. Let's see from the kubectl get all. See, this one, it is revised to the. So this is the fundamental of Helm chart, which is a package manager for Kubernetes. You can do a lot of things and it makes your life very easy from the CI/CD point of view. If you want to understand more details about the Kubernetes Helm chart structure, just go through their website and you will be able to understand what all things you can do, with when you are going to create the chart. Okay. And if you want to delete it, simple command is Helm uninstall name of your API. That is Helm, and all done. It's deleted. That's all on Helm. Let's jump to the next topic. So the final topic for today's discussion is container insight. So if you want to understand, the details of your container which you are deploying, on EKS or maybe, in Kubernetes cluster, how would you do that? So you need a log which can give you details at pod level. Container insight does exactly the same job for you. So to enable that, you need to follow certain steps. If you go through this link, right, which is published by Amazon, it talks about step-by-step details how to enable that. I'm not going to walk you through all these steps. You need to understand, through documentation. It is going to take some time, and go and follow the steps and execute it, and you will be able to enable your container insight. Or maybe you can also follow the steps which is given on the EKS workshop. So EKSworkshop.com is a workshop created by AWS, which you can follow. If you want to learn EKS in details, you can follow step by step. There's a lot of in-depth knowledge given here, and you can go through the demo part one by one to understand it. So In the EKS workshop, there's a section where it is talking about, how to install the container inside. You can follow this one. I'll give you a link of both, URL in description window. You can follow them. Once you have enabled this, you need to go through your application in the CloudWatch, and inside the CloudWatch on the left hand side, you'll find the container inside. And when you will click on the performance monitor, it will show you all the details of your particular cluster. So if you see here in the EKS cluster, I have selected my AWS test cluster. This is the cluster which we had created earlier, and I'm doing all the demo on this cluster. And it will give you details on CPU utilization, memory utilization, network, cluster failure, all the details. If you click, you'll find more details here, right? This is very useful, when you want to go and deploy in a production environment and you want to understand the, pod level details or CPU and memory level details for the particular node, right? There is another mechanism. You can also go for the EFK, which is Elasticsearch, Fluentd, and Kibana. You can also use, if you don't want to use the container inside, you need to just set up all those things. I'll give the link in the description window for the same as well. You need to go and follow the steps and deploy it. And in Elasticsearch, you will be able to see there, all the logs related to your container. The difference here is that container inside is a managed service. You need not to do any deployment as such, apart from enabling the container inside in EKS cluster or Kubernetes cluster. And through CloudWatch, you can see all the details. But if you're going with the EFK, you need to go and deploy and set up a, Elasticsearch cluster, either on any VM, or maybe you can use the Elasticsearch managed service from AWS, or you can deploy even Elasticsearch on a pod as well. That's all for today's session, guys. I'm planning to come up with the advanced demo session for Kubernetes in coming days. If you have not subscribed my channel, please do subscribe and click on bell icon so that you can get notified once new videos are uploaded. Thank you so much.